So today we're going to talk about Pascal's triangle. Pascal's triangle is a mathematical technique that's used to expand binomial expressions. So what do we know so far about expanding binomials? Well, we could easily expand something like x plus 2 raised to the power of 2. How do we do this? Well, we simply FOIL, right? How do we expand something like x plus 2 raised to the power of 3? Well, we could simply FOIL the first two terms, and then we multiply it by the remaining binomial, giving us the exponent of 3. Not too bad, right? But what if we have something like x plus 2, however, it's raised to the 5, or the 6, or this, whatever. Let's say raised to the 5. We're not going to FOIL the first two terms, multiply by the third, then the fourth, and then the fifth. We're going to simply use Pascal's triangle to help us. So what we will learn is an easier way to expand something like x plus 5 or x plus 2, whatever, to a very high exponent, in this case, 5. We will learn how to use Pascal's triangle in helping us with binomial expansions. What is Pascal's triangle? Pascal's triangle looks something like this. We have a structure of ones, and inside we have a bunch of other numbers. And how do we get these numbers? 1, 4, 6, 4, and 1. So, like I said, the structure of the triangle is all ones. But how do we get these numbers here? And by the way, this triangle can go on forever. We don't have to stop here. Just for simplicity, we will stop here. How do we get these numbers? Well, we look at the row directly above. So for this number here, 2, we look at the row directly above, and we have 1 plus 1, 2. This 3, again, looking at the row directly above, we have 1 plus 2 is 3. This 3, same thing. 2 plus 1 is 3. And this could, like I said, go on forever. Going down to the 4, the 6, and the 4, we have 1 plus 3 gives us our 4. 3 plus 3 gives us our 6. And 3 plus 1 gives us our 4. Great. We now know how to draw Pascal's triangle. But how does this help us with expanding something like x plus 2 raised to the 5? How does this help us? Well, let's get a new slide here. Let's say we want to expand x plus 2 to the 5. We're going to look at Pascal's triangle again. We're going to draw it out. So we have 1. Remember, the structure is all ones, so don't forget to draw the ones in. 1, 4, and then 3 plus 3 is 6. 3 plus 1 is 4, and 1 again. And then we can continue. 1, 5, 4 plus 6 is 10, 6 plus 4 is 10, 4 plus 1 is 5, and we close our structure with our 1. Again, we can continue forever. For this example, I'll give you a hint. We don't need to. We could stop right here. Does anyone see why we could stop right here? Well, it has to do with our exponent. Exponent is a 5. We look at our Pascal's triangle, and we simply look for a 5. We have a 5 right here. The 5 right after the structure indicates that this is our coefficients needed for the expansion of x plus 2 to the 5. So now, let's go ahead and expand x plus 2 to the 5. We're going to start with our first coefficient, which is a 1. So we have 1. And then we simply have x to the 5 Why is x to the 5? Well, because our question is x plus 2 to the 5. So we always start with simply our power on our first term. In this case, it's x. However, we do need to account for the 2 as well. So it's x to the 5 multiplied by 2 to the 0. Okay, but why is it to the 0? Well, our exponents in our expanded form, so here 5 and 0, they have to add up to the exponent in the original question. So here we have 5 plus 0, giving us our 5. Great, that's one term done. Let's continue. So now we look at our second coefficient, which is a 5. So we have 5. Again, we're going to have x to the 4 this time, because we simply subtract 1 from our exponent here. So if we're subtracting 1 from there, what is our exponent going to be on our value 2? Well, again, the 4 has to add up to the 5. So it's going to be a 1, right? Great. Now let's continue. So now we have a second term, or a third term, sorry, which is a 10. 10 bracket x and 2. But what are our exponents for our x and our 2? Again, we're going to look at our previous term. We're going to subtract 1 from our x, so we have 3. And we're going to add 1 to our 2, so we have 2 squared. Plus 10 again, because that is our next coefficient in our triangle. Oops. 10 again. And this time we have x squared 2 cubed. Just going to erase some of our triangle here. Now, we are all the way down with our 5s. So 5 is our coefficient. We have x to the power of 1 and 2 to the power of 4. Plus, our very last term is a 1. So plus 1 bracket x to the power of 0 times 2 to the power of 5. So looking back, if you look at all our coefficients in each term, they are simply deduced from the triangle that we drawn before. 1, 5, 10, 10, 5, and 1. Looking at our expansion, we have 1, 5, 10, 10, 5, and 1. Perfect. Now what about our exponents? Well, remember, our exponents in each individual term have to add up to the exponent in the original question. 5 plus 0 is 5, 4 plus 1 is 5, 3 plus 2 is 5, 2 plus 3 is 5, 1 plus 4 is 5, and 0 plus 5, again, is 5. So this right here, this entire equation is our expanded form of x plus 2 to the power of 5. Great. We have just expanded much easier than if we were to try to FOIL, multiply by the next term, and the next term, and the next term. That would have taken us so long, it would have gotten very messy. However, we could also simplify this, and we will simplify this in our final answer. Because all these terms, they could be simplified to a smaller term, right? So here we have 1 times x to the 5 and 2 to the 0. What is anything raised to the power of 0? What is that? That is simply 1. So this entire first term could simply be written as x to the 5. Going forward, we have 2 to the power of 1, which is 2, times our 5, remember, because our 5 is outside the bracket, so we times it after, times by 5, which is 10. X to the 4 stays as x to the 4. Here, we have 2 squared, which is 4, times our 10, which is 40, x cubed, plus here we have 2 cubed, which is 8, times our 10, which is 80. And then we still have our x squared as well. Here we have 2 to the power of 4, multiplied by 5, which is 80 as well. And we're left with x to the power of 1, which is simply x. And here, again, our x to the power of 0 goes to 1. So we have 1 times 1, which is 1. And then we have 2 to the 5, which is 32. So this, right here, would be our final answer. This is the simplest form of our expansion of x plus 2 to the power of 5.